Good morning, students. This is Professor Kiran Poddar, Angadi Institute of Technology and Management, Belagavi. In this session, we are going to discuss the procedure of finding Laplace transform of the given function. It is quite interesting because it is a product of three functions: t raised to 5, e raised to 4t, and cos hyperbolic 3t. We have a properties. First shifting property says if there is any other function which is multiplied by an exponential, shifting property can be used to solve that one to get a Laplace transform. Derivative property says if there is any function which is multiplied by a algebraic term like t square, t cube, t raised to 4, whatever it is, t raised to n, then derivative property can be used to get that one, to get a Laplace transformation. But here what happens, exponential is multiplied by another two functions, or else algebraic is also multiplied by another two functions. Therefore, this is very difficult to get a solution for this one, to come to common platform, common opinion ki which property has to be used. For that, what we do, initially we'll be taking the whole function, the given function as f of t. Here we will be taking t raised to 5, e raised to 4t into cos hyperbolic 3t as a function. So what we can do, hyperbolic can be converted into an exponential. Then the product of three functions where hyperbolic will be converted into an exponential, then exponential and exponential will get merged. Then it becomes product of two functions. That is quite easy. Therefore, what we do, we'll be taking t raised to 5, e raised to 4t, that into hyperbolic can be converted into an exponential. How it can be taken? This is nothing but 1 by 2 into e raised to 3t plus e raised to minus 3t divided by 2. That is already taken here, or else I'll take here. Okay, therefore f of t is equal to 1 divided by 2 will be taken as a common term. Then it becomes t raised to 5 into e raised to 4t into e raised to 3t, that is e raised to 7t, plus t raised to 5 into e raised to 4t into e raised to minus 3t, that is e raised to t. Fine. Now let us apply Laplace on both sides. Then L of f of t is equal to 1 divided by 2 into Laplace transformation of t raised to 5 into e raised to 7t plus Laplace transformation of t raised to 5 into e raised to t. As we discussed in a previous example also, where there is a chance, there is a chance of applying either shifting property or derivative property, better you go with shifting property, that is most convenient property. Okay, so for that what we do, we go with shifting property. Means if any of the other function which is multiplied by an exponential, that can be taken as Laplace transformation of that other function, where due to shifting, s exponential, that is s will be replaced by s minus 7. So that's a comes from exponential power, that is 7 here. So s minus 7 plus same thing here, Laplace transformation of t raised to 5, where s is going to be replaced by s minus 1 because t raised to 1 times t it is. Therefore, which is equal to 1 by 2 into, we know that the Laplace transformation of t raised to 5 is what? 5 factorial divided by s raised to 6, where s is going to be replaced by s minus 7 due to shifting property. Plus here again it is 5 factorial divided by s raised to 6, where s is going to be replaced by s minus 1 as a token of shifting property. Fine. Therefore, which is equal to 1 divided by 2 into 5 factorial is nothing but 120, that divided by s is going to be replaced by s minus 7 raised to 6 plus 120. S is going to be replaced by S minus 1 raised to 6. Therefore, 120 is common term that will be taken outside. Then it will get cancels with 2. Then it becomes 60. So it is nothing but 60 inside the bracket 1 divided by S minus 7 raised to 6 plus 1 divided by S minus 1 raised to 6. So this is the Laplace transformation of t raised to 5 e raised to 4t into cos hyperbolic 3t. Thank you.